my name is Enzo Carter, and today I'm going to be explaining how you can use quantum ghost imaging to see inside of a black hole. So the first thing you might be wondering is, what is quantum ghost imaging? In an earlier one of my videos, I made a whole video about this earlier, so you can go check that out on my channel. But the quick explanation is, it's taking a picture of something without light that reflected off that thing. Let me do a quick example. So let's say you want to take a picture of this box. Alright? Typically, you would have the camera sensor, and then you'd have some light that would come off the box, hit the sensor, and then you'd have a picture of the box. But quantum ghost imaging is a little bit different. Let me just get rid of this. Right, quantum ghost imaging is like this. So you have your camera sensor, sorry for my horrible drawing, and then you have the box you want to image. And what you would do is then you have special BBO crystal, or nonlinear optical crystal. I explained this in my other video. The light comes from a laser or something, hits this, and then it is split. I don't know why I chose to use yellow. Yellow is probably not a great idea. Let's use blue light. This is a little easier to demonstrate. And then the blue light at about 400 nanometers gets turned into two red beams. I think I drew this crystal in a bad position. I'll fix that in a second. But anyway, two red beams, so energy is conserved. So one 400 nanometer turns into two 800 nanometers, which is just outside the visible spectrum. So basically one of these, let me just fix this real quick. I don't know if this is actually fixable, but I'll figure something out. Okay, I figured it out. So we're just going to grab this and just move the camera sensor over here. See? Problem solved. So basically one beam, these are entangled, ignore that, one beam goes to the box and reflects off of it. And how did we lose that? Alright, then the other beam hits the camera. Alright, and then if we follow the camera's little wire to the monitor, then on the picture will have the box in it, right? So that's like quantum ghost imaging oversimplified somewhat. This might be wrong as well, so correct me if I'm wrong in the comment section, please. Okay, but here's how to use that same process to see inside of a black hole. So you'd have the blue light, or it really doesn't matter what wavelength. Excuse that. So blue light, BBO crystal. Oh, they have a letter. Okay. Alright, why did it choose that color? I don't know. Okay, this, I just want to kind of... What the heck are you doing? Alright, my computer's yelling at me now. Oh, no, stop it. I'm not allowed to delete this, apparently. Okay. Alright, I can fix this. So whatever, this is the BBO. And then you've got your two red beams that are transmitted. And then one of them will go to the camera's chip. Charge-coupled device, CCD, they're sensitive cameras. And then the other one will go to the black hole. No, you got it. This is a little better color. There we go, the black hole. And then the red light continues its travel. Oh no, then don't do that. Don't do what I just did. If it looks like this is like my first time using the Microsoft Paint, I think this is what that's called. That's because it is. So one hits the CCD, one goes in the black hole, and because these things, the entangled particles, can transmit not really information, because they're pretty useless if you're trying to send like a message, because it's like randomized, but you can make an image out of them, and they can do that faster than light, and a black hole's escape velocity is faster than the speed of light, so this should theoretically work. Of course, it's gonna be a while until we can test it, because of course the nearest black hole is like 1,000 light years, and we haven't really left our solar system yet. So yeah, that's how you can use quantum ghost imaging to see inside of a black hole. Hope you enjoyed, and please like and subscribe if you enjoyed the video.